Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called for writing fractions and mixed numbers as decimals. All right, this is going to use the steps of long division: divide, multiply, subtract, check, bring down. If you struggle remembering those steps, you could always use the acronym Does McDonald's Sell Cheeseburgers? I think most of you, though, probably are familiar with these steps, though, of long division. To set up a fraction in long division, I need you to stop thinking that the bigger number always goes inside of the long division. That's not always true. The numerator must go on the inside of long division. So a nice little way of remembering that is a cheesy phrase called top dogs in the house, which is a reference to the number on top goes on the inside of the so-called house, which is really just long division, but a cheesy little phrase to help you to remember the top number goes on the inside. Let's take a look at two examples that are already typed up for you on your notes. So we put the 7 on the inside and we're dividing by 40. And we ask ourselves, how many 40s can divide into 7? Well, it can't. So what do? Put a decimal point and then a 0 and then try again. How many 40s go into 70? One of them. Now notice I bring the decimal point up. 1 times 40 is 40. And then I subtract, next step, and I get 30. And then I check. I make sure that the number that I got from subtracting is smaller than what I was dividing by. Because if I subtracted and got something like 40 or 50 or 60, then that means I didn't go high enough up here when I divided. All right, since 30 is less than 40, I bring down a 0 and I repeat the entire process. How many 40s go into 300? You can think to yourself how many 4s would go into 30, and that would be the same answer then for how many 40s go into 300. So 7 of the 4s could make 30, so therefore 7 40s can make 300. 7 times 40 gives us 280. Subtract, we get 20. We double check. Is 20 less than 40? Yes, it is. So I bring down another 0, and you're like, Underkoffler, how long do you keep doing this? The answer is either when you finally get a remainder of 0 or when you notice a repeating pattern. So far, I'm not noticing any repeating pattern. How many times does 40 go into 200? Well, think how many 4s would go into 20, and that would be 5. So therefore, 5 of the 40s would make 200. 5 times 40 is 200. I subtract. I get a remainder of 0 finally, so the final answer is 0.175. Let's skip ahead to number 3 over on the far right of your page. Notice this time it was a mixed number. If you want to work smarter, not harder, just take the integer part of it and just end up dropping it when you're done with all your work to the left of the decimal point. So instead of 0 point something, if there's a mixed number part, in this case -5, then that's -5 point something. All right, the fraction part, 17 over 60, top dogs in the house. We put the 17 on the inside, and we start doing long division. How many 60s can make 17? 0 of them. So let's put a decimal point and a 0. Bring the decimal point straight up. How many 16s can make 70? Well, think how many 6s can make 17, and that's how many 60s can make 170. That would be 2 of them, because 2 times 6 is 12. So 2 times 60 is 120. Subtract, I get 50. I check, is 50 less than 60? Yes, it is. So bring down a 0. How many 60s go into 500? That would be 8 of them. 8 times 6 is 48. So 8 times 60 is 480. Subtract, I get 20. By the way, I'm doing a lot of the borrowing in my head. If you are not able to borrow in your head, then you could go ahead and do the borrowing right here like you normally would. But I really just asked myself, how far is 480 from 500? And I knew that was 20 away. So therefore, I don't really have to do the borrowing. I can just figure it out mentally. Is 20 less than 60? Yes, it is. So I bring down a 0. Man, this is taking a while. How many 6s can make 20? 3. So therefore, 3 times 60 is 180. How far is that from 200? It's 20 away again. Wait a minute. If I bring down another 0, 60 goes into 200 3 times. I would just be repeating what I exactly already did, where I would multiply and get 180 again, and then subtract to get 20 again. So this is a repeating pattern. Specifically, I kept getting 200 and 180, 200 and 180, and that came from a repeating 3. So notice when I write my final answer, bring that -5 in front on the left, 0.283, and since the 3 repeated, I put a repeating bar. All right, you can also take a look here. Problem number 2 was another example of a decimal that did not repeat. By the way, let's talk about vocabulary. This is a terminating decimal. Would you quickly go ahead and write that down? Terminating decimals are the kind that, if I can spell it, are the kind that do not go on forever. They stop. So to terminate means to stop. So a terminating decimal, which was what we had on number 1 and on number 2, is the kind of decimals that come to a stop. Repeating decimals are called repeating because they repeat forever. All right, problem number 4. Pencils ready. Let's do this together. Go ahead and start setting up the long division. Top dogs in the house. And unlike number 2 and 3, where there was a mixed number part, an integer or whole number, and then also a fraction, this is more like number 1, where it's going to end up being 0 point something. Now, don't write that down yet. Let's do this together. How many 12s can make 5? Well, it can't. That's the 0 part. Put a decimal point, bring it straight up. I hope you're writing this down along with me. And I just accidentally cloned my dark shade. Didn't need to do that. Let's put a 0. How many 12s can make 50? I hope you know some of your times tables of 12s. 12 times 3 is 36. 12 times 4 is 48. Ooh, 48. That would be really close to 50. So 4 of these 12s. Go ahead and write that 4 above. 4 times 12, boom, 48. And you can do this mentally. How far is 48 from 50? It's only 2 away. Ask yourself, check, is 2 less than 12? It is. So I continue on. Put another 0, bring it down. And repeat the process. How many 12s can fit into 20? If I did 2 12s, that would be 24, which is too high. So I'm only going to be able to do 1 12. So write a 1 up here. 1 times 12 would give me 12. Subtract. I'm going to do this mentally again. How far is 12 from 20? It would be 8 away. Is 8 less than 12? Yes, it is. So I put another 0 and I bring it down because I haven't noticed a repeating pattern here yet. And I haven't gotten a remainder of 0 either. How many 12s can make 80? Okay, I don't know how well you know your times tables of 12s. 12 times 5 would be 60. 12 times 6 is 72. If I do 12 times 8, I'm actually going to be over 80. So it's only going to be 6 of them. By the way, sorry, I should have said if I did 12 times 7, I would be 84. That's over 80. So this is why I need to only do 6 of them. So go ahead and write a 6 up here. 6 times 12 is 72. If you needed to go off to the side to figure that out, you would totally do that. Subtract. How far is 72 from 80? Well, that's the same thing as how far 12 was from 20, which is 8. And already I'm starting to think to myself, wait a minute. If I would bring down another 0, you see how I have 80 again, just like I had 80 here? This is a repeating pattern. It would be 6 times again. So I can stop my work right here. I know that my 6 is going to continue to repeat. So underneath the original problem, let's write down the final answer. And if you put your work underneath the original problem, then maybe put the final answer somewhere off to the side and circle it. It's 0.41, and then the 6 repeats. Don't write it with extra 6s. I want you to write this in the simplest way that you can. Yes, that actually matters. I know we only talk about normally simplest form with fractions, but even when you write decimals, you should write them in the simplest way. So don't say 6 repeating when you can just write it as 0.41, 6 repeating. Only 1 6 needs to be shown with repeating bar, which is why I didn't go up here and write a repeating bar there and circle that as my answer, because then I wouldn't have written it in the simplest way. All right, I will do one more with you. Number 5. Notice this is a mixed number. You can go ahead and start working smarter, not harder, and just write your final answer as 176.5. and then leave it like that for now. Let's take the fraction part, 13/40ths, top dogs in the house. 13 goes in the inside, 40 on the outside. We're going to ignore the 176. That's just going to go to the left of the decimal point. So how many 40s make 13? That'd be 0. Now, I know you're like, Underkoffler, I thought you said we're going to put 176, not 0. Well, follow with me here. 176 plus 0 would still be 176. So even though I'm putting 0 here, if I add it to 176, I still would get 176. Okay, so put your decimal point, and then bring it straight up, and then let's put a 0, and we're going to think of this as 130, even though it's 13.0. We're going to ask ourselves, how many 40s would make 130? And if you're like, I don't know how to do triple-digit numbers, simple. Think of 40 as just 4, and ask yourself how many 4s would go into 13, and that answer would be the same as how many 40s go into 130. So how many 4s make 13? It would be 3 of them. So 3 times 40, what is that? 3 times 4 is 12, so 3 times 40 is 120. All right, let's subtract. 0 minus 0 is 0, 3 minus 2 is 1, 1 minus 1 is 0, so this is going to give me 10. And is 10 less than 40? Yes, it is. So we will put another 0 and bring it down, as I had accidentally shown too early when I was doing this. And now we repeat the process. How many 40s go in 100? Think to yourself, how many 4s would make 10? And that's the same answer for how many 40s make 100. So how many 4s make 10? 2 of them, because 2 times 4 is 8. So 2 times 40 is 80. Write it down. Let's subtract. That's going to give me 20. Is 20 less than 40? Yes, it is. Put another 0. Bring it down. How many 40s make 200? Well, ask yourself how many 4s would make 20. And that would be 5 of them. So put the 5 up here. 5 times 40 is 200. Oh, well, that's nice. I actually get a remainder of 0. So I hope you have this all written down. What do I have up here? 0.325. Now, the 0, I already talked about this. 0 plus 176 is 176. So it's 176.325. This was a terminating decimal, the kind that does not go on forever. It stops. By the way, if I go too fast on any of these, you're always welcome to hit pause or even rewind if you need to hear something again or to give yourself time to write things down. I want you now to try number 6 and number 7 on your own. Don't forget, top dogs in the house. I kind of already started them for you here. So hit pause on the video and do these 2 problems on your own, 6 and 7. Then hit play when you're ready to see how you did. Okay, did you already do 6 and 7 on your own? If not, hit pause now. All right, number 6. Did you make sure the negative sign was in front of your final answer? Ooh, yeah, we got to be careful about that. We're not going to put negatives in our side work or long division work, but it does need to go here on the final answer. All right, how many 3s made 40? That was one of them. That gives you 33. Subtract, you got 7. You brought down a 0, making it 7D. How many 33s make 70? 2 of them. That gave you 66. Subtract, you got 4. You put another 0, and you brought that down, making 40. How many 33s make 40? One of them. 1 times 33 is 33. And I bet some of you started noticing something. Wait a minute. I feel like we've done this before. 40 minus 33, we did already do that. But what is repeating? Check it out. I'll prove it to you. How many 33s go into 70? That would be 2 of them. Ah, do you see it? The 1 and the 2 both repeat. So this is the first decimal that I've given you here on this page where both digits get the repeating bar. So it goes over 2 digits instead of just 1 because both of the digits repeat. And finally, problem number 7. All right, did you keep the negative 91 to the left of the decimal point on your final answer? If not, you need to fix that right now. Okay, how many 63s or 60s make 53. That was 8 of them. 8 times 6 is 48, so 8 times 6D is 480. Subtract, you would get 50. Then you brought down another 0, making it 500. That would go in 8 times again, because 8 times 60 is 480. That's the closest you can get to 500 without going over. Subtract, you get 20. Then you would put a 0 and bring it down. How many 60s go into 200? Well, you ask yourself how many 6s would make 20, and that would be 3 of them. 3 times 60 is 180. Subtract, you get 20, and then you would bring down another 0. And here's where you start to see a repeating pattern. You see how it's 200 again exactly? Now, I bet some of you thought the 8's repeated, but here was 530 minus 480. Here was 500 minus 480. So that was not exactly the same. So even though you got a double 8, it's not a repeating 8, because right afterwards came a 3, 200 minus 180, and then 3 times again, it would be 200 minus 180. If you would continue your work, the 3 repeats, not the 8. So here's the correct way of writing this. Negative 91.883 repeating. If you wrote 33 repeating, please erase the extra 3. You need to write this in the simplest way possible. Speaking of which, back on number 6, if you wrote negative 0.1212 repeating, please erase the extra 1, 2, even though it was up here in my work. When we write the final answer, we write it in the simplest way possible. And that concludes the guided notes on writing fractions and mixed numbers as decimals. Thank you for watching. We'll see you next time.